Okay, welcome everybody. Thank you all for being here on time. Today is January 7th, 2021. And in today's lesson, we'll talk about the scientific method. We are starting to get into the swing of things. So our normal routine calls for us to have a warm up every day, and you'll have 6 minutes to start that warm up. We do have a warm up today. It should be a pretty quick and simple one to do, and then we'll go over it. So you've got 6 minutes. The timer has started. You need to navigate through Canvas to our Unit 0 module, and it is Unit 0, Day 3. Unit 0, Day 3. so hopefully that was enough time to complete the warm-up. If not, again, I always remind you all that you have until the end of the unit to complete all of the assignments, including the warm-ups and exit tickets. And so for this unit 0, you will have until Monday, January 11th to complete the assignments. But we're going to go over this warm-up really quickly. I like that warm-up because it allows you all to do a little bit of data analysis and some scientific writing. So this is good preparation for some of the things that we will do in this class, and also just good preparation for science literacy in general. So you were shown this graph that should be on your screen right now. And you were told that a scientist moved a plant closer and closer to a light source while observing the rate of photosynthesis. The graph shows his results. Okay. The scientist could also be a person who uses she, her pronouns, or they, them, theirs. So we'll just say the scientist show, or the graph shows the scientist's results. But we can see in this graph, we've got this blue curve that's going up, and then it starts to kind of slow down as it moves up. So instead of just going straight up, or instead of curving the other way and starting to get faster as it goes up, it's kind of like a hill where it's steep in the beginning, but once you get towards the top of it, it starts to level off and become a plateau. Okay, so I think that's important because you all were asked to come up with some type of conclusion based on this graph. Before we can actually reach the conclusion, we need to know what the graph is telling us and what information we can take from the graph. So my first question of you all is, what is on the y-axis for this graph? What information is on the y-axis?
The rate of photosynthesis.
Excellent, thank you, Brianna. So we can see this. So the y-axis is what's called your vertical axis. So it's the one that goes up and down. Okay, so we can see that the rate of photosynthesis is measured by the bubbles of oxygen released. Okay, that's important. Thank you, Brianna. What's on the x-axis here?
The light intensity.
Good, the light intensity. And that's measured in just in arbitrary units. It's not necessarily given a specific unit like ohms or something else that you might hear in a more advanced science class. We're just told that it's just units. So the x-axis is your horizontal axis, and that means that it moves left and right. But we can see in both cases, we're moving up, we're moving to the right. So there's some type of directionality, there's some type of relationship that we can get here. So in conclusion, this is what you might say. As the scientist moves the plant closer to the light source, the light intensity is increasing or is it decreasing? What do you all think? If I move it closer to the light source, does the light intensity increase or decrease?
Increase?
Good, it's increasing. Good, so as the scientist moves the plant closer to the light source, the light intensity increases. So if we look at our graph, that means we're moving this way, we're moving to the right. The light intensity is increasing from 2 to 4 to 6 to 8, so on and so forth. And as that's happening, as the light intensity is increasing, the rate of photosynthesis is that increasing or is it decreasing? So as we go this way to the right on the graph, what's happening to this blue curve? Is it going up or is it going down as we move to the right?
It's going up.
It's going up. Thank you. Who was that? Abraham. Excellent. So yeah, that means that as the light intensity is increasing, meaning as we go to the right, the rate of photosynthesis is also increasing, meaning it's going up. Okay, so increases. So this means this is what we would call a direct relationship, a directly positive relationship. As one thing increases, the other thing also increases. That's why we call it a direct relationship, directly positive. It goes on to say, however, at a certain point, more light doesn't necessarily mean an increase in the rate of photosynthesis. So the graph levels off. Again, we can see it. It looks like this hill. It starts off steep, but then when you get towards the top, it starts to level off. This happens, or this starts to happen at a light intensity of about 10 is what I said. Okay, so we can see at about 10, the graph is basically level. It's not increasing much more at that point. So that's what a good conclusion would say. It allows you to take out information from the graph, and it tells you exactly what you are observing, or what you should be able to observe as a result of that experiment. Okay. So if you didn't finish your if you didn't finish your warm-up, then you should definitely take this information and try to incorporate it in your warm-up. And again, I'll just remind you guys, all of the warm-ups, exit tickets, and asynchronous assignments are designed so that you can attempt them at least 3 times. That's going to be good for you all to know and to use as a study mechanism. If you get towards a test and you have completed all of your assignments, it might make more sense to go back and redo some of them in preparation for that test. Okay. So today's objective, remember the acronym SWBAT stands for students will be able to. Would anybody like to read the objective for the day?
Students will be.
Go.
Go ahead, Kathy.
I could go.
Okay, I'll go. Students will be able to identify and apply the steps of the scientific method.
Excellent, thank you. And then the essential question. Anyone else want to read the essential question?
I'll read it. Why is it important to follow the steps of the scientific method when testing a hypothesis?
Thank you, Brianna. Okay, so again, we always want to start off with an objective and an essential question. It just gives us a direction and a goal that we hope to achieve by the end of the lesson. So I appreciate Kathy and Brianna for tag teaming on that one. I don't know, I think something was supposed to be there. Oh, well. So we are going to practice some note-taking skills for the next 7 slides. And I actually just remembered what was supposed to be on that last slide. Some of you probably, maybe all of you, saw what took place in our nation's capital yesterday. I don't want to spend too much time talking about it. I know that it was a potentially stressful event for us to witness on the news and on social media, but it's something that I think we need to make some type of connection to. So when we think about the scientific method, I do often think we're thinking about biology or chemistry or physics. We're thinking about these hard sciences, but the scientific method can be applied to our everyday lives. The scientific method just states a method of thinking. It talks about how we should be approaching a problem, how we should be gathering information about that problem, and how we can arrive at a logical conclusion. So when you all are processing all of the information that you're getting from your news sources, whether that news source is YouTube or Twitter or Clubhouse or TikTok, whatever you're using, or if it's traditional news sources like ABC or MSNBC or the New York Times, when you're processing that information, you've got to be able to decide, is what I'm reading and watching and hearing, does it really make sense? Is it true? Is the person who's saying it motivated to say one thing or another? Is the person who's saying motivated to influence a group of people to do something? Does this align with what I know to be true and the facts that I've already collected? Does this align with what has historically taken place? You've got to ask yourself these questions as you're processing all of these different news sources and bits of information, and that will allow you to arrive at a logical conclusion. Unfortunately, a lot of the people who stormed our Capitol yesterday have not arrived at a logical conclusion, and some of them is because they have been led astray, and for others, it's because they have chosen to see things in an incorrect and in a dangerous way. But the problem with their thinking is that they're not actually collecting facts. They're not doing the necessary amount of research to arrive at a logical conclusion to know what's true and what's not. So I want you all to in your high school classes, start now. And if you haven't already started, it's not too late to practice these skills, to start to ask questions of the things you're reading. That doesn't mean that you have to be skeptical of everything. It doesn't mean that you have to distrust everything that you see and read, but it does mean that you have to be able to say, that sounds right, but that doesn't sound right. Or I know that that person is motivated because they're making money, or they're being paid by someone else, or they want to have some amount of influence over me to try to change the narrative. So you've got to be able to have those skills and see what's true and what's not. And the scientific method is a great way for us to do that. So it's not just about biology. It's not just about science in general. It's just about a method of thinking, of critical thinking and problem solving that is going to be useful in whatever you're doing in life. Okay, so I just wanted to put that out there. And if you are stressed by everything that you saw yesterday, please do take a step back. I encourage everybody to get some time away from the technology, away from their phones, away from their Chromebooks. Too much information can be a bad thing. Okay, so I encourage you all to take care of yourselves in this time, and don't be overwhelmed by everything that you're seeing, because it's a lot, and we are in a precarious situation. So, guard yourselves. Okay. And then another quick reminder. So, and I do ask that you all have some notebooks ready to go at this point. And I would like for you all to write some reminders to yourselves in your notebooks. We covered these 2 assignments yesterday, so hopefully, and I know most of you did already complete them. I will be updating my gradebook on Saturday over the weekend, so you all will start to see things going into Power School. Of course, nothing will be marked late until Monday, or until Tuesday. So you have until Monday night to get everything turned in for Unit 0. But I do always want to make sure that you all are staying on track and not getting too far behind. So yesterday we assigned the Create Your Google Drive assignment, as well as the Design Your Own Virtual Locker assignment. If you have any problems with either of those, please don't hesitate to reach out and let me know, and I'd be happy to help. And then, of course, once you create your virtual locker, you should save it in your biology Google folder, and that's how you can share it with me. Okay, so those were the 2 assignments yesterday. We had warm-ups and an exit ticket yesterday as well. So I want you all to make sure you're staying on track. As long as you're not having any technical difficulties, I do want to make sure that you're still doing the work on a day-to-day basis. One more reminder, there was a parent-guardian requirement. I do want your parent-guardian to share their contact information with me. Most of the contact information is available on PowerSchool, but sometimes that information is outdated. So I want to make sure that I have the correct information, and this is not to punish you all. I don't plan on reaching out solely to, complain about your efforts or your performance. I often will reach out to parents and guardians and family members just to say, I'm proud of what your student is doing. I'm happy to have them in class. Please let me know if there's any way I can support them in anything outside of biology. So that's what I use the contact information for most often. So I want to make sure I have everything up to date. You can find this form in a number of different places. I've linked it into PowerSchool. It's in Canvas. It's in our syllabus. But in Canvas, you can find it specifically in our Unit 0 module, and then it's under Unit 0 Day 1, and it's called the U0D3 Student Champion Contact Form. Okay. So I do want your parents to fill that out for me. It shouldn't take longer than 3 minutes. Okay. All right, so we'll start our note-taking portion of class now. We should be able to get through this before 11 o'clock, which is when we will transition to the asynchronous portion of class. So as I stated, today we're talking about the scientific method, and this is a cool image on the right side that presents a flow chart of how you can move through the scientific method. We're going to talk about the different steps that are a part of the method, and I'm sure you all have heard about it before, and you probably talked about it in your earth and environmental science classes, and maybe even in middle school and elementary school. So this is nothing new, but this time I am, again, pushing you to think about this beyond the scope of just biology. This has implications and utility beyond just science. You could be using this every day, and you already are using this every day when you're processing information as you see it on your social media feeds, and you're saying, wait, that doesn't make sense. Like, there's no way that those two things happen, or that those two people interacted. So when you're questioning something, when you're being skeptical, when you're saying, actually, I read something different yesterday, so I got to figure out what's the truth. I need to do a little bit more work. What you're doing is actually applying a version of the scientific method. So in many ways, you're already good scientists. But the scientific method is defined as a planned, organized approach to solving a problem. What you all will notice is that in our lessons throughout the year, the text that is highlighted in either yellow or in green is typically what I'm asking you to write down. Okay, so here we've got a sentence that's highlighted yellow. There's another sentence here that's not highlighted that you don't really need to write down. This is the information that's going to be most important to you as we go. All right, so get in the habit of just kind of picking out those words that are highlighted. If you do want to add more, if you want to draw something, or if you want to write more notes, go for it. You know, I'm all for that, but I want you all to at least have the words that are highlighted written down, because that's going to give you the gist of our lesson. So there are many different approaches in taking or in using the scientific method. There are many, many different types of experiments, and some of you will probably go on and employ the scientific method, even if you don't end up going on to be a biologist or a chemist or some other hard scientist. Even people who are social scientists use the scientific method. People who are journalists use the scientific method. People who are producers use the scientific method. This is really just an organized approach to solving a problem. And we all face problems, regardless of what we do. Entrepreneurs face problems, and they have to go in and do trial and error, and they have to try and use different people or use different resources or try out different manufacturers or source their materials from a different place or a different company. So the scientific method is really a version of all of those things. It just allows you to solve a problem in a timely and in an organized way. So, of course, to begin, you need to identify a problem. And once you've identified that you have a problem or that there's some problem that is plaguing the system that you're observing, then you form a question about it and you state a purpose. You have to state a purpose as well. What's a one-word question that comes to mind when you think about the word purpose? Or the meaning of the word purpose? What's the one-word question that comes to mind? Not who, not when, not how.
A why?
Why? Thank you, Abraham. So we should always have an understanding of why. That's why we state the purpose. Why are we doing this research? What's the point? What is the implication of this problem? How is this problem affecting the community? How is this problem affecting the planet? How is this problem affecting the human body? Whatever it is, we want to know why this research is happening in the first place. Why are we even trying to solve this problem or to understand this problem? Then you have to do some background research. what might be some background research that you do? How might a scientist or someone who's doing the scientific method do some research? And feel free to use the chat if you're being a little shy or your microphone is not working. Feel free to use the chat to answer these questions. Again, the question is, what's an example of some research that people might do to solve a problem, or how might they research? I've got a lot of people here who I haven't heard from. I've heard from Brianna. I've heard from Kathy and Abraham. Anybody else want? Okay, Jason says use Google. Google is an excellent source. Now, I think a lot of people would be like, oh, Google, Google could come up with any number of answers and they're not all right. That's true, but Google, if you're a responsible person, Google can be a responsible search engine as well. So you do need to be careful with Google, but it can be an excellent resource. And then Jason says you can also go through notes that you've taken in the past. That's an excellent point. So a good scientist is always going to record their observations. You need to be able to record your observations because you want to be able to come back to them, and you can use your own notes and your own observations as research in future experiments. So that's a great point. Anything else you want to add? What's another type of research that people might do? Okay, so maybe we're struggling with that one. Abraham says, look at what other scientists or people think. Excellent point. Yeah, human beings are communal organisms. We need to live in community with other people. Even though some of you are like, nah, I'm an independent person. I like being alone. I love my alone time. I get it. I would definitely consider myself a more introverted person as well. I like my alone time also, but being able to compare thoughts with other people, being able to get feedback from other people, being able to discern how other people are feeling about your conclusions. That's an important skill to have. We need other people. We need to have other opinions. We need people to review our work. Okay, so that's a big part of scientific research, is having your peers, people who are on the same level as you, go in and review your work and say, this was really well done. The conclusion that they arrived at is logical and it makes sense. So this research, we can go ahead and say it is supported. But then also some people go in and say, sometimes the peers will go in and say, that doesn't make sense. They didn't follow the correct procedure. They cheated in their results. So we cannot say that their conclusion is correct. There's not enough support for their conclusion. Okay, so having other people is a great example of how you might do some background research. We can also think about doing interviews with other people. Okay, so firsthand accounts is an important type of research that social scientists do. You can also think about reading a book. It's not just the internet, but books can be excellent sources of research. You can do field research when you actually go out somewhere into the world and you do direct observations of things. We can think about the development of these COVID vaccines, and this is something you all will think through as a part of your asynchronous activity today. But obviously, that required a vast amount of research of the human body and of specific cells in our lungs. Okay, so sometimes it's what we call bench research, where you have to look through microscopes and conduct experiments with different chemicals. So there are all these different types of research that you should be doing in order to equip yourself to solve a problem. Then you have to form a hypothesis. Now, I know you guys know what a hypothesis is. You've been hearing about this since elementary school, I'm sure. What is a hypothesis? Someone, anyone? think there are two words that people often use to define a hypothesis. Okay, brainstorm. Good. So maybe before you actually form your hypothesis, you have to do some amount of brainstorming. Brainstorming would be kind of like step one, step two. Abraham comes up with a good word too. So a hypothesis is kind of like a theory. It's not quite a theory. A hypothesis is actually a little bit, we would consider that a little bit below a theory. A theory is actually a pretty supported idea. A hypothesis is an educated guess. And those were the two words that I was thinking about. It's an educated guess about the outcome of your experiment. So before you actually run the experiment, before you set up your variables and start to manipulate your variables, you want to have some type of prediction about how that experiment is going to go. If this happens, then this will happen. So that's often how you'll see some basic hypotheses scripted. An if-then statement. If it's raining outside, then the plants will grow by an additional centimeter. Or if the cloud is half an acre in size, then it will start to produce rain. So you can test that. That's something that you can actually go out and observe. So an if-then statement, that's what a hypothesis is. So if you didn't know or weren't able to define a hypothesis, then it probably would be a good idea to write down this definition. So I'll leave this on the screen for a little bit longer. Okay. Now keep in mind, I am recording the lesson, so this will be available to you. If you miss anything, you can go back and view it on YouTube. So step 4 is to design your experiment. Experimentation requires pretty precise design. You want to know exactly what you're going to do, when you're going to do it, how you're going to do it, what you need to use in order to do it. All of these things need to be tracked. They need to be recorded. That's because in a good experiment, you don't want to have any outside influences. You want to know everything that's happening so that you can say with a great amount of confidence that this led to this. But if you have all these other, what we call confounding variables, things that are having some type of effect on your experiment that you can't even control, then you can't necessarily say that this led to this, because it could have been something else. It could have been this other thing. So you need to have control over everything that's happening in the experiment. You want to be able to tinker with this, with one variable just a little bit, and be able to observe what happens to everything else. So a good scientific experiment will test only one variable at a time, and a variable is just a changeable factor. There are in general, two types of variables: the independent variable and the dependent variable. The independent variable is the factor that you're actually testing, the thing that you're manipulating. Okay, so this might be time. Let's say that I want to know what the effect of time is on how an egg is boiled. So I set up 6 different burners, and I put water in each burner. I start to boil the water. In my first burner, I'm going to leave the egg in for 2 minutes. In my second, 4 minutes. In my third burner, 6 minutes. Fourth burner, 8. Fifth burner, 10 minutes. And sixth burner, I'm going to do 12 minutes. And I want to see what the effect is on how those eggs get boiled. In that case, my independent variable is time because I'm the one who's manipulating the time. I did 2 minutes, 4 minutes, 6 minutes, 8 minutes, so on and so forth. My dependent variable is the factor that I'm actually measuring. So in this case, if I'm measuring what happens to an egg as it's being boiled, maybe I want to measure the hardness of the egg, or maybe I want to measure the color of the egg. Those would be dependent variables. Those things are going to change depending on which burner the egg is in, which pot the egg is in, but they're still things that I can measure. Now, in that example, just like I was talking about, I need to have some control over the environment of the eggs. And that's going to be important. You'll see that word control on the next slide. But this image here kind of tells you what's happening. The independent variable is going to be manipulated and it's going to control or lead to changes in the dependent variable. The independent variable leads to changes in the dependent variable. That's why we call it the dependent variable. It depends on the independent variable. Okay. So here's that word, constant. In my example with the eggs, I don't want to have 100 milliliters of water in 3 out of my 6 pots, and then 200 milliliters of water in 2 out of my 6 pots, and 50 milliliters of water in my last pot. Because that would totally change. I don't know in that case if it's actually the time that is changing how the egg gets boiled, or if it's the amount of water. I can't say for certain. So I need to be able to keep it constant. I only want to change one variable at a time. If I want to know the effect of time on how an egg is boiled, then I can only change time. Everything else needs to be constant. It needs to be the same amount of water in the pot. If I want to know how the amount of water affects an egg being boiled, well, then I need to boil the egg for the same amount of time, but with different amounts of water. Maybe I also want to know, what about temperature? Does it change if I boil the water at 215 degrees Fahrenheit and then 230 degrees Fahrenheit and then 245 degrees Fahrenheit? I can measure that as well, but in that case, I would need to boil them all for the same amount of time and in the same amount of water. Okay, so you can only change one variable at a time. Everything else needs to be held constant. You do not change it. This is how you know that the results of your experiment are actually a result of the condition they are being tested. You don't want to be confused and wonder, is this because of the time? Is this because of the amount of water? Is this because of the temperature? You should know exactly what it is a result of. Okay. And then the last few steps of the scientific method. You want to make observations and collect data. You should organize your data into graphs, charts, and tables, and then analyze that data. And then you can draw your conclusions. Now, again, some of you will go on to do actual research, and that should be exciting to you all. But as a part of doing your research, you've got to share it. The scientific community and the public need to know about your results. They need to be able to say, oh, this is how that person did that. That's really cool. And hopefully your experiments and your method is sound. You don't have any errors in it. And so the results that you're able to share are actually useful to the public. Oftentimes, these results are communicated in reports or in specific journals, sometimes in models, things that you might even see in popular social media, specific graphs or headlines, things like that. So at this point, are there any questions about anything we've gone over today? We are at that. We've got about 31 minutes left in class, so I want to give you all time for asynchronous work. If there are no questions, then we've got two things to do today. The exit ticket is a little bit longer today, and so I'm going to actually count it as its own assignment. You know, this typically is not what happens, but this exit ticket will be counted as its own assignment. It's called Scientific Method in Action. Of course, it's available on Canvas under the Unit 0 module. Oh, okay, Jason asks, what is the control group mainly about? Which slide would you like me to go back to, Brianna? This one or this one? Or even before that? The last one. Okay, so to answer your question, Jason, the control group just allows you, and sometimes the control group is, you know, you might have multiple, oftentimes you will have multiple control groups. So let me think of another besides my egg boiling experiment. Okay, so let's say that we want to know the effects of a specific steroid on athletic performance. So I've got 5 athletes who are going to be my test subjects. And I want to know how their athletic performance, let's say how well they can bench press. Let's say how well they can, how well they can bench press. I want to see how their athletic performance improves over the course of a month when they're using this steroid. I need to also have another control group, so another set of 5 athletes who are not taking the steroid at all, because I need to have a baseline. Okay, so that's what the control group is. So I've got those 5 athletes who are taking the steroid, and we can see how over time they change. They get better at bench press. And so they start off lifting 200 pounds, being able to bench press 200 pounds. And over the course of a month, they're able to get up to 350 pounds. Well, that alone doesn't tell me that much, because I don't have a bench line. How much improvement typically happens if you're bench pressing every day for a month without a steroid? The control group tells me that. I need to be able to say, okay, these 5 athletes didn't take the steroid, and they were only able to improve by 50 pounds. So they went from 200 to 250 pounds. Versus being on a steroid, you went up by 150 pounds, from 200 to 350 pounds. So you need that control group to say, without there being any manipulation, without me even using the variable at all, I didn't even give them the steroid. This is what the baseline is. And then I can compare that to what happens when I do manipulate, when I do give the steroid. Okay, so that's what the control group is. It establishes a baseline. Hopefully that made sense. But that was a good question. Okay. And then there's also a scientific method video web quest. So this is going to be a series of videos that you'll have to bounce around to. I did provide the link to the first video on Canvas, and I can actually send that to you all here just to make it a little bit easier. And then once you are done and you're able to navigate through the correct videos, you'll be able to answer the last question. That's a part of the activity. Okay, so those are the 2 things that I'm asking you all to do today. Tomorrow, we're going to take a diagnostic exam, which I'm going to give you all formal credit for, just for doing it. I'll give you 10 formal points just to do it. It's not going to be based on how well you do. I don't really care how well you do. I just want to have, again, my baseline. I want to say, all right, so Jason came in and he started off at this level. And then by the time we got to mid-February, he was here. And then by the time we got to mid-March, he was here. So I need to have that baseline to see how you all improve throughout the semester. It doesn't really matter where you start. We all know that the goal is to pass this class and to get a 4 or a 5 on the EOC. That's our goal. So I believe we can get there. So the link that I just sent to the chat should take you to those YouTube videos that I was just talking about. or at least the first one in the series. Please let me know if you have any questions. We've got 25 minutes left. I'm going to put myself on mute so you all can get to work.
So for the exit ticket, once we move it to the bio folder that we have, you could check it through there, or do we have to share it to you?
Once you move it into your bio folder, I'll be able to see it there. That's a great question, Kathy. I would also like it if you all could, on Canvas, if you could turn it in on Canvas. So there should be an option. Let me check right now. Yeah, so there's an option for you all to copy the URL to your exit ticket, and then you can submit that in Canvas, or you can download your exit ticket as a PDF or as a doc, and then you can submit that to Canvas as well. So I'd like for you to do it in both ways. Save it in your biology Google folder and also turn it into Canvas. Good question. Okay, folks, it is now 11:36, so I apologize. I lost track of time for a minute, but you all are good to go ahead and start your lunch break, and I will talk to you all tomorrow. I appreciate everybody being here and working hard today, and I hope you have a good rest of your Thursday.